Hello, welcome to this video for Year 13 Mathematicians on using the product rule. So I'm going to differentiate this. I've got u equals 3x squared minus 5x. V equals e to the 2x. I always set it out like this. Du dx so is 6x minus 5, and the v dx is, remember to bring down the 2 to e to the 2x. It's handy to draw these little lines to remember how you're pairing them up. So I've got v times du dx, e to the 2x times 6x minus 5. Just put dy dx here. So that times that plus that times that. Plus 2e to the 2x times 3x squared minus 5x. There you go. Now, we could leave it like that, but there's a good chance you might have to go and find a stationary point. So you want it in a different form for solving. In that case, I would take a factor of e to the 2x out. And then what do we have? So we've got two lots of 3x squared there. So 6x squared minus two lots of 5x minus 10x. Notice I have to double these two because it's 2e to the 2x there. Be very careful when doing this. And then 6x minus 5 is multiplied by e to the 2x here. This is a useful step if you're going on to find a stationary point. And I'll just explain why further in a second. 6x squared minus 4x, bring these two together, minus 5. Now if you're asked to find a stationary point, it's when this dy dx, the whole thing equals 0. You can then say, well, when this bit's 0, that's your stationary point, so you could solve that. That's the reason we would do that. So I've got another couple of examples just to get you fluent with using this rule, because this technique, the product rule, is absolutely crucial. So here we have e to the 3x sec 2x. Now, sec kx differentiating is in your formula booklet. So I wanted you to be aware of that and make sure you can refer to the formula booklet and use it. So I'm going to go ahead and differentiate this now. I'm going to call u e to the 3x. V is going to be sec 2x. Du dx is 3e to the 3x. dv dx, now be careful here. If that's sec kx, what we do is we put that number there in front, so we've got two lots of it. We still have a sec 2x, but we also have a tan 2x. So if that were 5x, sec 5x, it'd be 5 sec 5x tan 5x. That is in your formula booklet though. Now we do this. dy dx equals 3e to the 3x multiplied by sec 2x plus, we've got two lots of all of this, two lots of e to the 3x multiplied by sec 2x tan 2x. Well, that can be simplified for the same reasons again. You want to make it easy to find a stationary point. You see e to the 3x is in both, and so is sec 2x. So we take out e to the 3x, sec 2x as a common factor. And then we have 3 plus tan 2 tan 2x. And this would make it easier for you then to go and find stationary points. One more to look at. Y equals cos ln x. I always like to throw in differentiating cos because we get a common error here. Cos x is u V is ln x. Also like to make sure you can differentiate ln x. It's going to come up in your exams, so make sure you can do it. Students tend to make errors with these. So du dx is negative sine x. Just remember that differentiates to negative sine x. Ln x differentiates to 1 over x. And it's useful to remember the vice versa for when you're integrating. Again, I've seen students forget that. Dy dx is going to be these two. So you're going to have negative ln x sine x plus cos x over x. And you can't really simplify that too well, so we'll leave it as it is. 3 examples on using the product rule. Make sure you get that method down, you're comfortable with it, and you've practiced it plenty. Hope that's clear. Thank you.